All right, so adding radicals. Adding radicals. Concept's not hard. When you're adding radicals, you're going to end up a lot of times with a radical, because that's what you're adding. The concept is exactly this. It's just like adding like terms. So that's what goes in the blank there. And we already know how to add like terms, right? So it's just like adding like terms. You know, 5 of them and 2 of them is 7 of them. It's just like adding like terms. However, you have to notice one thing. In order to add radicals, they do have to be like radicals, just like they have to be like terms. Can you add a 3x and a 5n? No. Can you add a 3x squared and a 2x? Ask it again. Can you add a 3x squared and a 2x? No. They're both x's, but the one's squared and the other's to the first power. You can't add them. Now remember, a radical is just, you can change a radical into exponent form, can't you? Isn't a square root something to the what power? 1/2 power, right? The radicand's exponent divided by the index. Can't be forgetting that. It's the first thing we did this chapter, right? A square root is something to the 1/2 power. A cube root, however, is something to the what power? 1/3 power. So see how they're not the same? And therefore you can't add a square root and a cube root. So let's suppose you had the square root of x and the cube root of x. You can't add them. They're not like radicals. Same concept as like terms. So only like radicals can be added, which are radicals with the same index and the same radicand. You got to have both the same index and the same radicand. Both have to be the case. All right, that's not earth-shattering. So how do we add them? Just like adding like terms. And numbers of you still continue to leave off the parentheses when adding the coefficients. And I don't know why, but you do. And I keep trying to remind you and remind you and remind you and remind you that that parentheses is important. And the plus minus means I'm showing you how to do it, whether it's addition or subtraction, right? So you just add up the coefficients, the things out in front, and it will be that many of them, right? So A of them plus B of them gives you A plus B of them. So if we had 2 times the square root of n plus 3 times the square root of n, that would be 5 times the square root of n. 2 of them, 3 of them is 5 of them. Piece of cake. No sweat. Easy, right? You can do it. You guys like stayed up till 1 o'clock last night? What, watching the Golden State game, I guess? Watching Colby drop 60? Is that what it was? All right. Or you girls stayed up watching, I don't know what girls watch. Ballerinas, I don't know. I don't know what you watch. Gymnasts, I don't know. No idea. All right, got to get some energy here. You guys are dead. All right, wake up. There we go, energy. All right, awesome. All right, so, you know, a problem like this, piece of cake, we don't need to use the parentheses in the rule. We're just going to simply add the coefficients, right? So we're just going to go 5 plus 2 is 7, right? Of them. Ooh, that was hard. So no one's going to miss any of these, right? Just like I thought you wouldn't miss the cube root of 3 times the cube root of 7. All right. But a few of you managed to miss that one. All right. So don't miss these, all right? Do not do that. So something like C, go ahead and you do it while I do it, but it's way too easy. Seven positives and 13 negatives leaves you 6 negatives, right? Negative 6 times cube root of 5. Don't forget your index. Don't forget your index. Don't forget your index. Don't forget your index. Who forgets the index? Let's see, out of you guys. Who are the index forgetters? There are other index forgetters out there, I know. Ethan? See, I went to him already in the beginning. Okay. Get it? Do you get it? Don't forget the index. Do you get it? You don't get it. Do you get it? Do you get it? You do? I don't think so. Do you think he gets it? I don't think he gets it. Do you get it? Yeah, he might get it. Who gets it?
Andrew gets it.
No.
Tell me what it is then.
Which one?
What you get?
I get the index.
Do you get the analogy?
Yeah.
What, you do?
No.
Now, yeah, that's right. Now I don't think he does. Anybody getting the analogy?
What's going on?
Josh? Huh? No. Come on. What's with you guys? You don't get it? She doesn't even get it. Nobody gets it? Do you get it? How about you?
Something from a preacher.
No.
Come on.
What is this?
It's a vowel.
She get it.
Hey, a vowel.
You get it. You get it. Taylor. You know what? I'm not going to tell you. Ah, that's great. I'll let you think about it. Somebody will finally get it. All right, here we go. Let's do D. All right. What finger is this?
Oh, that's the end.
It's the index finger! Oh, I've been pointing at you!
Well, now it gets stupid.
All right. Okay, so go ahead and do a D. Should be a piece of cake, no sweat. Oh no, a minus the minus. Oh my. And it's a fifth root. Surely I can't do a fifth root. I don't even know what they are. Like what times itself 5 times equals the radicand. All right, and where do we end up with, what, 4 of them? 4 times the fifth root of 11, right? No sweat there, nothing earth-shattering, nothing you can't handle. I got another one? What in the world? Why in the world did I do another? And another one after that? And another one? All right, what's E? Negative 6 times the square root of 5? Oh, you know, my oh my. Why did I even... Negative 6 times the square root of 6. I don't know why I even wasted ink on that one. Right, wait. Yeah, negative 6 times the square root of 6. All right, everybody okay with that? All right, what's next? So go ahead and do F. Go ahead and do F. Are you done yet? So what'd you get? Negative 4 times the square root of 13. Anybody get that? Negative 4 times the square root of 13? No? Good. Because that's not right. What did you get? Say your answer. Go ahead, say it. How about the square root of 7 minus 5 times the square root of 6, right? How many got that? Because you can't add them, right? You can't add them, but that is the answer. You would write an answer down if that were a question. That is the answer, the original. You can't add them, right? They don't add. All right, do G. Do G. Do G, do G, do G. That's for all you Cary Grant fans. You don't know what that is. You're too young. Unless your parents are Cary Grant fans and you've seen some of his old movies. So we got negative 4 times the square root of 6 plus 4 times the square root of 7, right? No sweat. Question so far. Anybody? Raquel. Say again. So the second one, 3 of them, and 1 of them is 4 of them, right? What else? Any other questions on any of these? Anybody? Anybody else? Okay. All right, so here's what will get you on these easy ones. So first thing that might get you is you'll try to add them up when they're not like radicals. But then you'll finally get that down and say, oh, I can't make that mistake. I better not add them when they're not like radicals. So then you'll take a look at something like A, and you'll say, they don't add. Because you got a square root of 2 and a square root of 18. That's not the same radical. They don't add. But you would be wrong. So why are you wrong? Andrew? Because you can simplify. So what we need to fill in, always look to simplify the radicals whenever possible. This can result in like radicals that can be added. And look, simplifying is something you're always looking out for. Think about your quiz yesterday. Didn't that get some of you? The aspect of you weren't always looking to simplify? You always need to be looking to simplify, always. So when we look to simplify and we say, oh, an 18 is a 2 times 9, and we all know the square root of 9 is 3 because a 9 is a 3 times 3, a 3 times itself 2 times. So now can we add them? Oh yeah. 3 of them minus 6 of them gives you a grand total of negative 3 of them, right? And again, just be careful. If you can't do that in your head without making a mistake, then just write the next step. It's not worth the 3 or 4 seconds to write the next step if you're going to make a mistake. Does that make sense? But I'm just telling you, and you know, you should put an asterisk by this thing because for some reason students forget it, and you always got to look to simplify. Always look to simplify. Okay. All right. So why don't you try B? Go ahead and do B. It looks to me like I have 15x of them plus 2x of them for a grand total of 17x of them, right? 17x times the square root of 3. How many of you got that correct? So, you know, again, simplifying. What's the square root of 25? 5. Because it's a 5 times 5. You want to keep going, keep going. But we all know square root of 25 is 5. What's square root of 4? 2. Get a 2 out. What's square root of x squared? X. Get an x out. Now you have 15x times the square root of 3 plus 2x times square root of 3. And so we're adding like terms in the process of adding like radicals. And we're adding, not multiplying, so just keep straight what you're doing. Questions? Okay, some of you keep missing and you don't ask questions, and I can't help you because I can't read your brain to know what's going on in your brain to know how to answer your problem. So you got to ask questions. All right, go ahead and try C. Got it? That one doesn't have a whole lot to simplify, right? All you've got is a 40, 5 times 8. Again, most people know the cube root of 8 is 2. If not, keep factoring the 8 till you get 2 times 2 times 2. Again, we get a 2 out. 6 of them plus 1 of them gives me 7 of the cube roots of 5, but I cannot add a square root with a cube root, right? So 7 times the cube root of 5 minus 7 times the square root of 5. How many got that correct? All right. Again, tricky, but I'm trying to expose you to things you got to be careful of, right? You got to beware of the index. What if those were both cube roots? For some reason, students routinely miss this question. So let me throw it in as a bonus. Don't write anything, just think. If perchance this were a cube root and that were a cube root, I want you to get in your head what the answer would be, because I find students miss this, which is a shame. So let's get this cleared up. All right, so on 3, out loud. Now, those of you that are shy and you're not sure you're right, I need you to say it out loud. Otherwise, I'm going to have to call on you and ask you your answer, okay? Because this is why I do this, so I can figure out what everybody's saying, all right? On 3, 1, 2, 3.
0.
Okay. 0 was the predominant answer, but it wasn't the only answer. Anything minus it is 0. You have 7 of them minus 7 of them is 0 of them. 0 of them is 0. So that's 0. So don't make that mistake. That's a 0. 7 minus 7 is 0. 0 times anything is 0. But again, you have 7 of them. Take away 7 of them. You have nothing left. You took them all away. It's 0. All right, try the last one. Go ahead and do that last one. Now you got to combine the previous lesson with this lesson, right? That's the way math goes. Combine the previous with the current. Okay, so if you didn't get finished, that's okay. Just look up. Let's make sure we understand the process. So the first thing is I've got to multiply those two together. It's a multiplication distributive property, right? 2 times 3 is 6 in front. I already notice that the radicand that has the square root of 6, the 6 in it, and the radicand with the 2 in it, I'm going to be able to simplify that. So I'm going to leave it 6 times 2. Now, if I were doing the problem, I would already take the 2 out. But I just want to be clear for you. Most of you have missed that. You don't do that in your brain. The second distribution. All right, 2 times a negative 4 is a negative 8. And again, I already know that the square root of 6 times 6 is a 6, and I would have written negative 48 there, but I'll do it that way for your sake. So that's the front part. Plus 3 times the square root of 2. Let's finish the simplification process. Again, now notice that a 2 indeed does come out. So that's a 12 times what? The square root of 3? Oh, nothing's going to add? Who made this problem up? What a bummer. Nothing adds at the end. I don't like that. So what do we end up with? 12 times the square root of 3 minus 48 plus 3 times the square root of 2. How many got that correct? All right. And if I would have made a better problem, something would have added up when we were done, but it didn't. Questions on that? The rest of you can get started. Anybody have a question on that I can help you with? Anybody? All right, adding radicals, just like adding like terms. But look to simplify, because that's what'll get you.